Let's talk about implicit functions and implicit derivatives. Sometimes it is convenient to define y as a function of x not by a traditional explicit formula, something like y equals sin x square root of x squared plus 1, but with the help of an equation, x squared plus y squared equals 36. In this case, we say that y is an implicit function of x. Just because it's not given by an explicit formula, we say it is an implicit function of x. Then, if we need to find derivative of y prime of x, we can possibly proceed in two ways. First of all, we can solve the equation for y, get some expression y equals something with x, and differentiate that. Or we can differentiate the original equation with the help of implicit differentiation method. The issue with the first way is that it might not work, since there are some equations that are impossible to solve for y and get some explicit formula. And the second option is usually the most efficient and the most convenient. Let us use the first approach to solve this example. Assume that y is implicitly defined by an equation x squared plus y squared equals 36 to find the value of y prime at a point and find an equation of tangent line at a point. So the first approach was saying that we need to solve for y first. That's what we're going to do. Solve x squared plus y squared equals 36 for y. So move x squared on the other side and get y squared equals 36 minus x squared. Then take square root of both sides. Get y equals plus or minus square root of 36 minus x squared. Then, since we're working with a point 5 square root of 11, we have the positive y coordinate, so we're choosing the positive formula for y. And the square root of 36 minus x squared is the same as 36 minus x squared to 1/2 power. Then we need to work on the derivative of y. It's going to be derivative of this expression. And with the help of chain rule, we're getting that it is the same as 1/2 36 minus x squared to negative 1/2 power times the derivative of the inside function, 36 minus x squared. So this boils down to 1/2 parentheses 36 minus x squared to negative 1/2 power multiplied by negative 2x. What will happen here, if we have a good look at, there is 1/2 and then there is 2, so those two things will be possibly cancelled. And after we clean stuff up, we'll get the expression negative x square root of 36 minus x squared. So we'll have negative x on top, and all of that divided by square root of 36 minus x squared. So that's our formula for the derivative. And then after that we get that y prime, when x is 5, is equal to negative 5 divided by square root of 36 minus 5 squared. Which works out to be negative 5 over square root of 11. That's our first answer to the first question. Then for the equation of tangent line, we pretty much know everything we need, because the slope of tangent line is exactly the value of the derivative, negative 5 over square root of 11. The point is given, 5 comma square root of 11. So for the equation we can use point slope equation, and that's y minus square root of 11 is equal to negative 5 over square root of 11 times x minus 5. And we can easily solve this for y and get this final answer. Now, to illustrate the second, more efficient approach, we'll solve the same problem using the implicit differentiation. What we start with, we take the equation x squared plus y squared equals 36 and differentiate both sides. So we're gonna do derivative of the left hand side, and it should be equal to the derivative of the right hand side. Derivative of x squared plus y squared is equal to derivative of 36. Then work this out. On the left hand side it is derivative. It is derivative of the first term plus the derivative of the second term. On the right hand side we're gonna get derivative of 36, and that is 0. Then we notice that for the second term, derivative with respect to x of y squared, we will use chain rule because there is a mismatch of variable. There is y inside and there is x that we are finding derivative with respect to. So we'll have 2x plus d with respect to dy of y squared multiplied by dy over dx. And after that we arrive at 2x plus 2y times y prime equals 0. dy over dx is the same as y prime. Once we're done with differentiating the equation, we solve it for y prime. So we move 2x on the other side to get to y prime is equal to negative 2x. Then we divide both sides by 2y to arrive at y prime is equal to negative 2x divided by 2y. And since 2 could be cancelled here and there, we get negative x over y. That's our expression for y prime using implicit derivative. Notice that if we plug x equals 5 and y equals 11 into this formula, we arrive at exactly the same result. Y prime is equal to negative 5 over square root of 11. And since we have the same value of the derivative, we'll get exactly the same equation of the tangent line. The slope is negative 5 over square root of 11, and the point is 5, square root of 11. So the point slope equation looks like y minus square root of 11 equals negative 5 over square root of 11 times x minus 5. And we can solve this for y and arrive at the final version.